migrating is not actually hard because the code is hard. It's hard because you don't know what you have to do until you've basically finished it. At 50 engineers, the whole thing descends into chaos and you take months or years to finish anything of even moderate ambition. By the time they actually decided to hit merge, they still had 33,000 at TS expect error tags in their code base. 33,000 places where they knew TypeScript was going to throw an error, and they decided to ship anyway at that point. Migrations aren't slow because the code is hard. They're hard because learning happens while you're already doing them. Welcome to Turn Stories. I'm your host, TR Jordan. Today, we're going to do a deep dive on one of the most counterintuitive facts about migrations. And that's that migrating is not actually hard because the code is hard. It's hard because you don't know what you have to do until you've basically finished it. And that's not a big deal if you're a solo developer and you have a small project. You just adjust. You learn as you go, no big deal. Even if you've got a team of 3 people, drop a note in Slack. Everyone adjusts. It'll be fine. But as you start to work on bigger teams, you work on more complicated migrations, a team of 10 might need a meeting, a longer email, a note in the wiki about how you're doing things. And at 50 engineers, I don't know. I've never seen it done particularly well. And most of the time what happens is that information gets left out, people get left behind, the whole thing descends into chaos, and you take months or years to finish anything of even moderate ambition. And that's challenging. And we talk a lot on this channel about how people have addressed that in the past. What are some of the ways that some of the companies that you've heard of, like Datadog and Slack and Twitter, have addressed those challenges? But you know what? It's 2025. We've got some new tools in our tool belt. So today, I want to walk through 3 real migration stories, but take a different lens to them. I want to show you how AI could have helped those teams learn faster, share faster, and finish their migrations faster. So let's go. All right. For the first chunk of this, let's talk about how AI can help you learn more up front to accelerate a migration. Because so much of the effort of doing the migration is learning how it should go and what should be done. There are ways to make sure that you can learn this. And I want to take as an example here the Flow to TypeScript migration. If you're not familiar, Flow and TypeScript are both typing engines for JavaScript, JavaScript not having types of its own, and static typing's having a bit of a moment in the last couple of years. It's incredibly powerful. It just happens to be a great assistant for AI coding agents. But even before this, the companies that decided they wanted to see the future and they wanted to add typing to their languages, companies like Stripe and Pinterest and Airbnb and Zapier, they had a choice to make because in 2015, there were multiple options for JavaScript. Flow seemed like a great choice. It had stronger React integration, had some great momentum behind it. TypeScript still seemed pretty immature at the time. Turns out all those companies picked Flow, and they were just 100% wrong about who was going to win. TypeScript is the clear winner here, and they were all stuck with a choice. How do we get off of Flow? When do we move to TypeScript? The question wasn't where they're going, it's when they were going to do it, how they were going to do it. Each of these companies has done a great write-up on their experience here, and they all took roughly the same approach. There is an open source library out there, a code mod effectively, that will migrate you in one big jump from Flow to TypeScript. Normally, that would be a little bit scary because incremental migrations are safer and more predictable. But in this case, having Flow and TypeScript live side by side in the same code base is a nightmare. It's just not something you want to do. So the workflow is you run the code mod, you see how much how well it works, you test it, you make the fixes, you reset everything, commit your changes back to the open source library, and run it again. If you look at the write-ups from each of these companies, Pinterest took months to do this. Stripe took a year before they were confident in making this change. Same thing with Airbnb, same thing with Zapier. And there was, in this story, you can see exactly the problem of they were learning how to do the migration because they didn't know when they were going to be confident in their ability to actually make the changes. And this is the first lesson I want to take from this, is that it doesn't make sense to have all of these companies working against an open source language, and yet it's all their own projects. The reason that happened is because in every one of those cases, their migration was unique. Their code base had unique challenges, unique usages of flow that needed to be fixed in that open source library before they could use it. And yeah, 80% of the work was reusable, but what I take away from this, and what I think you should too, is that if you're going to use any given tool, you're going to have to make it work for your code base. And that's going to be a huge part of what actually drives your migration time. If you're human, this is frustrating. Your time is limited, and by the time you get into actually making the changes, you don't want to go back and replan or rework things. AI can chase a lot more dead ends than you. Setting AI off to go figure out what needs to be done and how it can be done is a huge uplift, because it can get ahead of you and tell you what the lay of the land is before you actually get there. So I'll give you an example. Within Flow and TypeScript, there is a relatively simple change that you can that's modern JavaScript has introduced: anonymous functions defined in line. If you want an anonymous function to return an object, you simply wrap it in curly braces. Easy. If you want to wrap a TypeScript function in curly braces, that you need to make sure that you are disambiguating between returning an object and returning a type in front of an object. So in TypeScript, you need to wrap any typed returns without an explicit return statement in parentheses. CodeMod didn't handle this case. Stripe had to go and fix that deliberately because they were extensive users of a pattern where they wanted typed returns from anonymous objects. It's not the most common pattern in the world. It only has to be fixed once, but it's extremely likely that within your code base, you're going to run into those kind of edge cases. And if you can find a way to leverage AI to go read your entire code base, read the entire changelog, the entire flow definition, the entire TypeScript definition, you're not going to turn up every single one of these weird edge cases, but you'll turn up the ones that matter for you. So that's the first lesson here. What else can you learn before you actually get into making these changes? The second one, in the case that I noticed as I read through these stories, is that there is the developer experience to consider. Simply making the change, in the case of Stripe, everyone woke up one Monday morning and their code base was suddenly in TypeScript, which is kind of magical. But now everyone has to know TypeScript. So at Pinterest, for instance, they ran developer experience sessions. They had people who would show up and learn TypeScript. And this echoes what we've talked about on Turn Stories as well. Hal talked about moving from CoffeeScript to React. They had to go teach everyone how to use React first. So even if your technology is well known and you're moving to the latest and greatest, there is a new set of syntax you have to learn. And in every single one of these migrations, they had to consider, how do we make sure that people are comfortable with the new technology? And you can find, again, this is something that you can use AI to go find what may be problematic. What they found across these migrations is, for instance, the Flow ecosystem is stable. Stagnant, maybe. The idea is within TypeScript, and one of the big reasons for moving to TypeScript is there is a vibrant third-party ecosystem. But of course, having a vibrant third-party ecosystem, especially in JavaScript land, means that there's a lot of churn. So people had to learn to update their dependencies, run a yarn install or an npm install when they were debugging. There was also explicit differences between the type engines. Flow has exactness as a default, but TypeScript pushes much more strongly for gradual typing, so their defaults are relatively untyped. These kind of quirks mean that people will need to learn how to change their own workflows. And as part of any major migration, you, as the person who cares about this, are going to have to make sure that everyone else is successful with the new technology. And having a list of these things up front, well documented, well explained, with ways to learn more, is something that, yeah, you could do, but it takes away from your ability to actually go do the technical work itself. This is a huge area for AI to go dig up those details and those edge cases and share them with everyone else. The plan really does depend on what you learn at the beginning, and it'll stay more stable, and you can teach people and educate your coworkers if you can front load the plan. there was a really specific example here within Stripe's case that I found interesting. They did not fix all of their types, obviously, in one big go. They didn't add perfect strong typing everywhere. By the time they actually decided to hit merge, they still had 33,000 at TS expect error tags in their code base. 33,000 places where they knew TypeScript was going to throw an error, and they decided to ship anyway at that point because they wanted to get off of the old technology onto the new technology. And they understood that if they shipped with those exceptions in place, those were known knowns. Those were errors that they could deliberately suppress, and they could burn them down afterwards. And better yet, they could share with their team exactly what was still to be done. So they weren't dumping the thousands of developers at Stripe into a world where there's unknown unknowns and landmines everywhere. They'd actually gone through and inventoried it beforehand. But of course, doing that inventorying takes work. There's no better technology that I can think of to go dump reams of information, 33,000 errors, into a computer and have it sort it and organize it for you so you can come out with an explicit way to march through the problems. It echoes what I heard at Slack when Madeline talked about burning down the errors on a test migration. Having a list of known errors gives people the confidence to move forward, but even better, knowing how serious those errors are and doing a little bit of triage and investigation on those errors can give yet better confidence that you're in a state where it is okay to move forward, even though you're not at 100% yet. So I thought those are fantastic blog posts, and you should absolutely read them. I'll drop the notes in channel, I'll drop the links to those blog posts in the description of the video. Pinterest, Stripe, Airbnb, and Zapier all did this same migration. And what they learned is that every code base is different. So even if you're working on the same project as 100 other companies, think about how it'll work uniquely for your company and your code base, and use AI to figure out those differences as early as possible. All right. I would love to be able to learn everything up front. But TR, what if you can't learn everything up front? What if you discover something midstream? That's obviously always going to happen. When I was thinking about this question, the story that came to mind was Ryan King's telling of the Twitpocalypse. This was a repeated set of issues scaling how they stored tweets in the early days of Twitter. Early on, it was just a single MySQL database. They used signed integers because that happened to be the default in MySQL. That gave them about 2 billion tweets before they ran out of storage, and they had to upgrade from 31 to 32-bit, from 32 to 64-bit, 64-bit to multiple on one machine to multiple machines. And what they found is that they kept learning the lesson that every single change was fractal. They needed to go find what were the small things that they didn't know, and then they needed to share them as broadly as possible, because the thing that defined their schedule was the communication. It was how the people around them reacted to this information, because their mental bandwidth wasn't infinite. I'll give you an example. The easiest version of this was their 31 to 32-bit migration. Just go from unsigned integer or signed to unsigned integer. And actually, with a couple of database tricks, this is like an alter query in MySQL that takes about an hour to run. No big deal. They had 6 weeks to do it. Seems like plenty of time. But they needed to make sure that everyone knew it was going to happen. And not just everyone at the company, but their third-party ecosystem, because this is before Twitter had closed off access to the API in a lot of ways, and didn't even have an official mobile client. So they needed to go tell everybody. And what they found is that they didn't know how their third-party developers were going to react. So they simply told them as early as possible. And that gave them almost a month for everyone to react. And that mental bandwidth that they gave those teams meant that that first migration was successful. Similarly, going from 32 to 64 bits, what they found is that they figured this would be simple again. Tell everyone externally, tell everyone that they needed to make a couple of updates. But in 2009, 32 to 64 bits was not actually so simple. The problem that they found is not that everyone had to make a change. It was that the core libraries that people were using to store Twitter IDs did not support 64-bit integers by default. You had to go find a version in Ruby, in Java, of the libraries you used to represent your tweets and go change them, because people were using libraries that didn't have 64-bit integer support, database libraries that didn't have 64-bit integer support. And that ended up being the problem. And actually, it was mostly a problem internally because they were using Rails as their monolith. They're moving increasingly to the JVM and Scala. And internally, they had to tell everyone, you probably have to go look at your libraries and do this evaluation. And that takes time. So yeah, absolutely, you could use AI. But the lesson that I actually take away from this is not that everyone should be using AI for everything. Like, that's a great feeling, and I don't disagree. But more importantly, you need to share that information as fast as possible. Because if you don't know exactly what you're telling people to consider, you're telling them to go do an evaluation, do real work. They need time to internalize it, to think about it, to pick the right path going forward. And that means being as clear as possible on what you found and how it's communicated. Twitter didn't have Slack. Slack didn't exist at the time, which is now the de facto way to go communicate with your team internally. But even then, having been at Slack, I've seen plenty of channels that nobody reads. Getting a coherent, concise plan in front of people really makes a difference. And being able to say, this is what we've learned, this is how we learned it, and this is how you should act on it, buys that time. Making that fast is where I actually see a huge opportunity here. And in conversation with Ryan, he talked a lot about how the planning and communication was the important part of that project. Giving people, if you're running one of these projects, as soon as you learn something, make sure that you do as thorough an investigation as possible. Share that information as broadly as you can. So that's the first bit. The interesting piece about the next saga in that story is that everything got much harder. Once you're on 64 bits, great. That's a lot of integers. I don't. 2 to the 64 is far more tweets than they'll need for a very long time, though I did hear recently that Twitter is about to exhaust those. They needed to scale off of a single machine. And the interesting thing that they did there, and you should absolutely go listen to the episode, is moving to a different ID generation system. So IDs could be generated in a distributed fashion using a technology called Snowflake. What they discovered is, as you are rolling out 64-bit integers, JavaScript nominally supports greater than 32-bit integers, but it's not an integer type. That one number type that's baked into JavaScript actually is a hybrid type. If you're a JavaScript developer of any experience, I'm sure you've tripped over this. The numbers 1 and 2 and 5 and 2 to the 10 and 2 to the 50 are all represented precisely. But as soon as you cross over 2 to the 53, JavaScript represents that as 64-bit float. It's no longer precise enough to represent an ID. And what they actually had to do there is that they shared that information as fast as possible. And they moved to offering strings of IDs. So JavaScript could go parse it correctly. It turns out that the fact that IDs are numbers is not important. They just have to be unique identifiers. But that wasn't good enough, because a string ID requires meaningful change in a number of clients. And what they heard by publicizing that information quickly is that not all of their internal and external clients were going to have enough time to use the string IDs instead of a number ID. It's just too far of a bridge given database architectures or caching architectures or the libraries they're using. So it was kind of a bummer. Ryan actually had to go back and change the starting date for these IDs in order to buy more space. That he'd set the kind of 0 date for these IDs at the time that Jack tweeted the first public tweet, just setting up my Twitter. But that meant that by the time you got to the current day, they were generating integers that were over 2 to the 53. and that was going to break everyone who hadn't managed to switch to string clients. So they ended up moving the epoch up to essentially the moment of launch. And that meant that the IDs that were being generated in real time were still less than 2 to the 53. So even if you were affected by this bug, you still had a few months to go deal with it before the new IDs crossed over 2 to the 53. And that lesson here is so interesting because small changes can be huge, and you need to be able to research midstream, what are your options? What could you change? Where are the real dead ends? And that, again, is where I've seen a lot of folks today using AI to essentially parallelize their efforts. You don't want to slow down your migration. You don't want to stop doing the work because you're up against the clock. But if you can send an AI off to figure out, hey, are there other options here? Hey, how widespread is this problem? Can we go prove a different piece? Brian spent weeks running Snowflake to prove that it was going to generate totally unique IDs. The more you can use AI on those lower value or verification tasks, the better you can become, and the more time you can spend on the things that matter. So being able to figure out the scope and gather more information allows you to communicate more effectively, and that communication is really frequently what will drive the success of a migration. You need to be able to listen to those signals and take them seriously, and AI can lighten that load. What if you learned something that is material to the project? Everything within Ryan's story was minor signals. Simply communicate faster. Simply tell people that a library was updated. But what if the change you discover in flight changes the entire shape of the migration? What if you've learned something that is going to fundamentally change your approach? I've hit this. My last project at Slack was GovSlack. The simplest product spec you've ever written, at least in the first 3 lines. We want to take Slack and we want to deploy it in AWS GovCloud so it can be used by people who need a higher level of security and compliance. What we learned during this project is that the smallest details define the schedule. We learned this again and again and again. So this was my project from before the beta through GA launch, through getting compliance. And it required 300 people at Slack to contribute. It required 50 different teams to require. It was a behemoth. I'm incredibly proud of what we accomplished, but I gotta say, if I had known then what I know now, I think we could have gotten it done a year earlier. Okay, what do I know now? I want to talk about AppArmor. One of the core sets of compliance requirements here is FedRAMP High. There's 600 separate controls in FedRAMP High, and they are dense. I blissfully did not have to read them. I had amazing security partners who helped me interpret and understand them, but I got pretty familiar with them. There are a set of configurations that you need to handle. Things like your application needs to have minimal access to the files, libraries, and network resources in its baseline configuration. CM3, you need configuration change control. Your application should not alter its security posture live, and everything should be audited. AC3, access environment. It implements mandatory access controls. As we read through how we wanted to tackle this, we had a couple of ideas, and in many cases, the requirement is simply auditing, least privilege, good configuration. You can accomplish this with what you need. What we realized as we went through this is that we weren't quite meeting the bar across a number of different services. We needed to implement AppArmor. AppArmor is, if you're not familiar, a way to essentially configure how a binary on typically Linux, as we were doing, interacts with its environment. What system calls is it allowed to make? What changes to the running binary is it allowed to make? Typically, none at all. The interesting thing here is that this actually ended up being the long pole in the tent for submitting our compliance requirements. This is the scoping. We didn't know that we were going to do AppArmor at the start. We were hoping that we could get around to it. I think the interesting thing here is that we lost a couple of months because we were unsure of exactly how bad this was going to be. This scoping was a real activity, and it took us a couple of months of experimenting and prototyping, working with people who are actually going to have to implement AppArmor, because Slack has dozens of services in the critical path and hundreds overall. They'd all have to implement it. Making sure that we understood how this work was going to be done was the work. And the thing that really turned the corner for us is that once we decided this was going to be done, it was fairly straightforward. It did take a quarter or something to get everyone to implement, but early on, we lost that time because we didn't know how to do that scoping. And we were unwilling to stand up and make that call because we needed more information. And AI here can help set people up for success because you can share context. You can do honest, objective scoping partially, and then layer human judgment on top of that. Having AI give us this kind of shared reality that we could trust. And yeah, you have to build a trusted shared reality with AI to make sure you're not getting hallucinations, but it can be done. That can give you an enormous lever to go have human conversations about scoping. I'll give you an example that's even earlier from that. When we were building the environment, at some point we had to rotate all the secrets, exercise you have to do if you're doing high compliance work like this. The team that took the longest took twice as long as any other team. And the reason for that is because they had twice as many secrets. It's a manual operation to do that. Not every one of those is automated, especially in a heterogeneous, complex environment. This is pretty typical at that kind of scale. And what I noticed during that process is that we were unsure of how long it was going to take, in large part because we had to get that information again as a scoping exercise. And it turns out that if you're the person who's asked, hey, how long is it going to take you to rotate secrets? And you give a number that you know is going to drive the schedule of this, priority 0 project for the company, and you say, well, I need 2 more months than everybody else, that's not an easy answer to give. And it's not an easy answer to hear. The organization doesn't want to hear it. What I really learned during that is that you need to pay attention to what you're asking people to look at and where scoping can be an activity that is subjective versus objective. Seeing the reality of the work is something that engineering manager, she did an amazing job sticking up for her team, making sure that it was clear, but there was still distrust because it was simply a conversation. Bringing data to the table allows you to have much more confidence that you are truly seeing an outlier. And having that data allows you to marshal the entire team around, yeah, this is what we need to do, and refocus on, we are going to support that team in rotating their secrets. We're going to support the teams that need to migrate to AppArmor. And that refocusing is only something you can do when you have confidence and when you have data. And I know that going forward, I'm not going to make this mistake again. I know that as we do migrations and we figure out how to move forward, I need to be able to see the data. So I'm not simply asking people, can you do it? Or can I bully you into a shorter schedule? Because the work is the work and you can't get out of it. So in every migration, one small thing becomes the long pole. You got to find it, and AI can help you find it before it burns your schedule. So that's it. Migrations aren't slow because the code is hard. They're hard because learning happens while you're already doing them. And there's a real opportunity for AI to help you speed up that learning at the beginning of the project, to help you communicate and help your teams learn faster in the middle of the project, and to understand what is truly the long pole in the tent. You can research harder, you can share those learnings, you can spot that schedule defining detail. And this is all muscle you can build. AI today is in a place where no product is perfect, but the more you use it, the more you're comfortable with it. And if you can start to use AI, even in little pieces, to go build shared data truth, to build migration plans, and to give teams a space to go organize and interrogate what they are going to do, you can start to pull information forward in a way that allows migrations to really feel like they're on rails. AI isn't going to replace migration planning, but it can make teams learn 10 times faster. And that is the real bottleneck.